Could we terraform the moon? When we think about terraforming, the first place that usually comes to mind is Mars. It is the classic target for science fiction and future colonization plans. But the truth is that terraforming is a concept that could be applied to any celestial body, as long as the right conditions and technologies are available. So instead of talking about Mars, let's look up at our sky and think of something much closer: our own moon. The moon, Earth's only natural satellite, has fascinated humanity for thousands of years. Imagine how incredible it would be to see it in the night sky, not as a lifeless gray rock, but as a small blue and green world, like a miniature Earth. For fans of science fiction, it could resemble Endor from Star Wars, without the Ewoks, of course. But before we dream too much, we need to understand the reality of the moon. It might look close to us, but it's actually farther away than most people think. The average distance between Earth and the moon is about 384,400 kilometers. It seems near only because the moon is large enough for us to see it without a telescope. Illustrations in books often exaggerate its size and closeness just to make it easier to visualize. Here is a simple way to understand it. If we take the Earth's diameter, about 12,742 kilometers, and divide the Earth-Moon distance by that number, the result is roughly 30. That means there could be about 30 Earths lined up between our planet and the moon. Even so, the moon is still far closer to us than Mars. When Apollo 11 carried Neil Armstrong and his crew, the trip took just 3 days. In comparison, a journey to Mars would take 150 to 300 days, depending on launch speed, planetary alignment, and how much fuel is used. So if we want to terraform somewhere, the moon would clearly be easier to reach than Mars. But how would we actually terraform it? Bombarding the moon with comets. One possible method is extremely ambitious: bombarding the moon with comets. It sounds like science fiction, but it has been seriously studied. Physicist and astronomer Gregory Benford ran the numbers and concluded that about 100 Halley-sized comets would be enough to create a primitive atmosphere. The idea would be to find comets in the Kuiper Belt, far beyond Pluto, and redirect them toward a giant planet like Jupiter. Jupiter's gravity could be used to slingshot the comet onto a trajectory toward the moon. A few days before impact, the comet would be carefully detonated into smaller fragments so that they couldn't escape the moon's weak gravity. After the first impacts, the moon would gain a thin atmosphere. Because the moon has only 1/6 of Earth's gravity and lacks a magnetic field to shield it from solar wind, the gases would slowly escape over time, lasting only about 10,000 years without additional maintenance. But with each new comet, things would change. The moon would start spinning faster, reducing its current 28-day rotation period to about 60 hours. Its axis might also tilt slightly, allowing it to have seasons. The comets would bring water and carbon dioxide, but we'd also need nitrogen and help from biochemists to seed the lunar rocks with algae capable of releasing oxygen. From Earth, under the right alignment, the moon could shine up to 5 times brighter, reflecting sunlight off its new oceans. What life could be like on a terraformed moon? It wouldn't be exactly like Earth. The moon would remain an exotic world. With only 1/6 of Earth's gravity, waves in the ocean could reach 18 meters high, letting surfers ride for kilometers. And if the atmosphere became as thick as Earth's, a human could strap on a pair of wings and glide through the air like a bird. It all sounds like pure science fiction, but in theory, with enough technology, it could be possible. Paraterraforming, a more realistic option. There's another idea called paraterraforming. Instead of trying to transform the entire moon, humans could build enclosed, self-sustaining cities under massive domes. The concept involves covering large areas of the lunar surface with interconnected greenhouses, creating a breathable atmosphere inside. Each section would be separated for safety, but over time, the structures could be expanded and joined to form enormous habitable zones. This type of environment has already been studied on Earth. In the 1990s, there was a project called Biosphere 2 in Arizona, USA. It was an ecological experiment that simulated 7 different ecosystems: a desert, an ocean, a savanna, a rainforest, a swamp, farmland, and a human habitat. Although it faced many difficulties, such as food shortages, oxygen problems, and conflicts between the residents, it provided valuable insights into the psychological and social challenges of living in a closed environment. NASA has taken these lessons seriously, as any long-term space exploration would require humans to live in isolated habitats for extended periods. If you're enjoying this fascinating exploration of what it would take to make the moon our second home, make sure to like this video and subscribe to the channel. We upload new science videos every week, and your support helps us create even more content like this. NASA's real plans for the moon. Unlike giant comet impacts, NASA's current plans are far more realistic. They are considering the terraforming of a single lunar crater, or at least turning it into a habitable base. One candidate is the Shackleton crater, located at the Moon's south pole. It is twice as deep as the Grand Canyon and likely contains significant amounts of frozen water. The idea is to first populate the crater with solar power stations and robots. The robots would redirect sunlight to the interior, gradually transforming the area into an oasis for future human explorers. This approach is far more achievable in our generation. Robots could build the infrastructure long before humans arrive, preparing the Moon for long-term human presence. Terraforming the Moon entirely might remain science fiction for now, but para-terraforming and lunar bases are very real possibilities within this century. Would you rather terraform the Moon first, or focus on Mars, or even Venus? If you found this video interesting, make sure to subscribe to the channel and check out our other videos about space, science, and the future of humanity. Thank you for watching.